Pluto's atmosphere is a complex and fascinating enigma that continues to baffle scientists. Imagine a world so distant that it takes over 5 hours for sunlight to reach it, a place where temperatures plummet to nearly minus 400 degrees Fahrenheit. And yet, despite these extreme conditions, Pluto boasts a surprisingly dynamic atmosphere. The atmosphere of Pluto was first detected in 1988, when astronomers noticed that it had a thin layer of gases surrounding it. This discovery was made through the phenomenon known as stellar occultation, where Pluto passed in front of a star, causing a temporary dimming of the star's light. This dimming revealed the presence of an atmosphere. So, what makes Pluto's atmosphere so intriguing? For starters, its primary component is nitrogen, much like Earth. However, it also contains traces of methane and carbon monoxide. As Pluto orbits the Sun in its highly elliptical path, the distance between Pluto and the Sun varies greatly, meaning that Pluto experiences seasons that last over a century. This extreme variation causes significant changes in its atmospheric pressure and composition. When Pluto moves closer to the Sun, its surface ices warm slightly and sublimate, turning into gas, which replenishes the atmosphere. Conversely, as Pluto moves away from the Sun, the gases condense back onto the surface as frost, causing the atmosphere to thin dramatically. This cycle of sublimation and condensation creates a constantly changing atmospheric landscape. Adding to the mystery, Pluto's atmosphere is much more extended than initially thought, reaching up to 1,000 miles above the surface, which is remarkable given Pluto's small size. Another intriguing aspect is the presence of haze layers that form at multiple altitudes within the atmosphere. These hazes are likely due to the breakdown of methane by sunlight, creating complex hydrocarbons that fall and collect on the surface as a reddish-brown material, contributing to Pluto's unique color. The New Horizons mission, which flew by Pluto in 2015, provided the most detailed data about Pluto's atmosphere to date. It revealed that the atmosphere is much colder than expected. Instead of being warmer close to the surface, like on Earth, Pluto's atmospheric temperature drops with altitude. This temperature inversion was surprising and is not fully understood yet. In addition, New Horizons found evidence of Pluto's atmospheric escape. Nitrogen, the main component of Pluto's atmosphere, is being slowly lost to space. The mission observed a tail of nitrogen streaming away from Pluto, similar to a comet's tail. This process is incredibly slow, but over millions of years, it can significantly alter the planet's atmospheric composition. Interestingly, the loss rate of nitrogen is controlled by a balance between the surface's supply of nitrogen ice and the escape rate into space. This delicate balance means that any small change in surface ice could drastically affect the atmosphere. Another puzzle involves the presence of clouds. While no definitive evidence of clouds was observed by New Horizons, scientists believe they could exist intermittently, given the right conditions. These clouds would be composed mainly of nitrogen ice and would add another layer of complexity to our understanding of Pluto's weather and climatic processes. The interaction between Pluto and its moon Charon also plays a role in shaping its atmosphere. Charon is so large relative to Pluto that the two bodies are sometimes considered a double dwarf planet system. The gravitational interactions between them are significant enough to influence each other's geology and atmosphere. In particular, Charon's gravity can affect the distribution of surface ices on Pluto, which in turn impacts atmospheric composition and pressure. Scientists are also intrigued by the possibility of an atmospheric collapse. As Pluto moves further away from the Sun over the next century, temperatures could drop low enough for the atmosphere to freeze and collapse entirely onto the surface. This collapse would temporarily strip Pluto of its atmosphere until it gets closer to the Sun again, and the cycle of sublimation restarts. This potential atmospheric collapse is a unique phenomenon, not observed on any other body in our solar system, and adds a layer of intrigue to our study of Pluto. Understanding Pluto's atmosphere not only helps us learn more about this distant world, but also provides insights into the atmospheres of other icy bodies in the outer solar system. The study of Pluto's atmosphere is a reminder of the dynamic and ever-changing nature of space, where even the most distant and seemingly inhospitable places can surprise us with their complexity and beauty. In conclusion, unraveling the mystery of Pluto's atmosphere is an ongoing journey, filled with unexpected discoveries and puzzling questions. Each new piece of data brings us closer to understanding the processes that shape this distant world and expands our knowledge of the universe. As we continue to study Pluto, we are reminded that space is full of mysteries waiting to be unraveled, each one offering a glimpse into the wonders of our cosmos.